Hello students, I am Manish Singh, Assistant Professor in Computer Department in Asoit College. Today we are going to learn the fundamental concepts of computer network. So first of all, we have to understand what is computer network. Computer network, it's a combination or it's a connection of two or more PCs with each other using a wired or wireless connection in that you can share data or you can exchange information. So we come to the next topic. The next topic of fundamental of computer network is topology. Basically, there are five topologies: mesh, star, bus, ring, and tree. This is first of all, what do you mean by topology? Topology is a geographical representation of a computer network that is called topology. So first of all, we start with the star topology. Okay, as you can see in the presentation, uh, the structure of star topology. In that, you have seen there is a one central device that is called hub. That is a central device. In that, all the devices are connected. Now, first of all, we understand how your star topology works. First, we understand with the help of presentation. After that, we are going to perform the same topology in a Cisco packet tracer. Okay, first of all, we understand what is star topology and how it works. In that star topology, each device has a dedicated point-to-point link only to a central controller, usually called a hub. Means the devices are not directly connected. They are connected via central device. No direct traffics and link between the devices. Means no PCs they can directly communicate with each other. If they want to communicate, they first send the data to the hub. First of all, you understand what is hub. If I'm taking one example, hub means is a central device. Suppose if you take the example of IT hub, when you talk about, suppose this is the place that is called IT hub, means all the IT companies are located over here. That's why it is called IT hub, and means it's a central of the IT company. That's why it is called a hub. That's why hub is a central device. Means if the two, suppose this is a PC, this is a PC1 and this is a PC2. If they wants to communicate, first of all, PC1 sends the data to hub. Now the hub is going to broadcast the data. It not unicast the data, it broadcasts the data. Because the reason that, because hub is a non-intelligent device. Is it not intelligent means it cannot unicast the data. It will broadcast to all the points, all the devices. Means suppose PC once send the data to hub, it will broadcast to all the devices, and the packet goes to each and every devices, and the devices first check whether the if their destination address match, it will receive the packet, otherwise it will drop the packet. This is how your star topology works. Now we come to the advantages of star topology. Less expensive, as you see the figure, in that we need a less ports, less links, and less devices, so that make it more less expensive. Easy to install and reconfigure. If you want to add one more PC in a star topology, you can directly connect it to the hub, and you can make it in a computer network. Now, the third point is robustness. The network is robust because you can rely on this network. Okay. The disadvantage, single point of failure. Means single point of failure. If your hub is going to down, your complete network is not working, because all the devices are dependent on a central device. That's why it is called a single point of failure. This is the main disadvantage of star topology. Now we are going to learn, understand this star topology with the help of Cisco Packet Tracer. Basically, Cisco Packet Tracer, it's a simulator. First of all, we have to understand what is simulator. Suppose if you want to make a network of 100 PCs, and for that we have to need 100 PCs, 100 connections wire, but this is not physically feasible. So that we can use a simulator, in that you can perform all the practical, that is almost that will give the real uh, feel of the installation of computer network. So first of all, how you can use this Cisco packet tracer. In this Cisco packet tracer, we have to find in the left corner all the devices. First of all, we have to select the end devices, means you have to select the PCs. Suppose we have to use PCs. First of all, in that you can drag and drop the PCs from the given devices. Suppose I am going to make a network of 4 PCs. Okay. First of all, I am taking 4 PCs, or now I'm take one laptop. Okay. Now in this network, I have 5 devices, 4 laptops and four PCs and one laptop. Now I'm going to use a central device. So first, now and then I'm going to select the central device, that is called hub. Okay. This is a hub. First of all, I have to check how many ports in the hub. There are 6 ports, 6 RJ45 ports. In a computer network, we are using RJ45 port for connecting devices or for making a PCs that can be connected to a network. Okay, so we can connect maximum 6 pieces in this topology. Now in the figure you can see we have 5 devices, one central devices. Now I'm going to use a cable. For that you have to select from this option. Now this is how I connect device to a hub. First of all, I'm going to connect all the devices to a hub. Okay, this is how I connect all the devices to a hub one by one. Just this is drag and drop and clicking from first device, then hub. This is called the physical connection of star topology. Why I'm called this is physical connection? Because this is physical connection. Just I have connected all the devices via wire, but I am not configuring the network. What do you mean by configuration? Basically, when we talk about configuration, means if you want to communicate in a network, we need IP address. First of all, just I am giving one brief about IP. The full form of IP is Internet Protocol. It's a unique identification of a device in a computer network. So I have to give the address to each and every device. So that this is called IP configuration, TCP IP configuration. Okay. So first of all, I start from PC1. First, I click on the PC1. Then I am going to the desktop. In desktop, I am going to the IP configuration. Okay. In that, you have seen there are number of fields: IPv4 address, subnet mask, default gateway, and DNS. First of all, we have to understand what is IP4 address, subnet mask, default gateway, and DNS server. Okay. Suppose this is a small LAN network, means it's a local network. So we cannot use default gateway and DNS server. We are going to use only IP address and subnet mask. Suppose I am giving the IP address of 10.0.0.1. This is the IP address, means it's a IPv4 and it's a 32-bit address. Now I'm going to the subnet mask. Why this is subnet mask is 255.0.0.0? Because it's a class A IP address. In a class A IP address, the first octet is a net ID and the remaining is the host ID. That's why the subnet mask is 255.0.0.0. Okay, I think it's understandable to all. Okay, I have configured the PC1. Now I'm going to configure the PC number 2. Again, I'm going to the desktop, IP configuration. Now I'm giving to the IP address 10.0.0.2 because IP is universally unique. You cannot give same IP to another device. Okay. Now I'm going to given the subnet mask. Again, I'm going to the PC number 3, then desktop, then I'm going to IP configuration. Then I'm going to give the IP address 10.0.0.3, and this is subnet mask. I have already configured 3 devices. Now I'm going to the laptop. In laptop, desktop, IP configuration. Now I'm going to give the IP 10.0.0.4. Now subnet mask. Okay. Now I'm going to give the IP to the last PC number 5, desktop, IP configuration 10.0.0.5 and subnet mask. Okay. Now my computer star topology is completely configured. First of all, we have take the 5 devices. Then we are going to take a one hub. Then we connect all the devices with the hub. This is called the physical configuration. After the physical configuration, we are going to use a TCP/IP configuration. In that, we are going to give IP to all the devices. Now my network is completely ready. Now I have to check whether my network is working or not. So first of all, we are going to use a CLI command, computer command line interpretation. So first of all, I'm going to PC1, then I'm going to command prompt. Now I'm going to use a command that is called ping, P-I-N-G, ping, then space. Then I'm giving to the IP address of the another device where I'm to check whether my packet is received or to the next device or not. So I am giving the IP address of laptop, that is 10.0.0.4. Okay, now I'm giving the enter. Here you can see in the screen, you are getting the reply. Means your packet are going to be received by the PC number 4, or you can say the laptop. Suppose if I am taking another IP that is called 6, and everyone knows the 6 number IP is not in the network. So whether I check what kind of message we are getting. Okay, you are getting this message, request time out. When your packet is not delivered at the time, you are getting this kind of message, request time out. Okay, from this message you can understand, when you get the reply means your packet will delivered, and when you get this message request time out means your packet is not delivered to the destination. Okay, now we can check with the another example method how your packets travels from PC to hub and hub to another PC. Okay, it's a graphical representation. First of all, you take the packet. Okay, then you click on the first device. It's a source. Now you click on the destination. Then you go to the simulation. Okay, in simulation, now I'm going to play. Okay, you have seen this. The packet from PC1 to goes to your hub. In the previous slide, I have told you hub is a non-intelligent device. It will broadcast the packet to all the device. Now you can see. Okay, your packet will broadcast to all the devices. Now the packet will deliver to all the devices. The only that devices will receive the packet that has same destination address, and other devices will reject the packet. Now the PC2 acknowledge the packet to the PC1. If I am received your packet, you see the PC1 got the acknowledgement. I think this is the best example, and you can see the practical implementation of star topology, how your star topologies work. You can implement the star topology with the help of Cisco packet tracer. Okay, it's a one kind of simulator. I think everyone understand how your Cisco packet tracer works. Okay, now we are going to